Hi, welcome back to this beautiful YouTube channel. How are you guys doing today? I'm so excited right now, right? Because this is supposed to be the last class I'll be doing for this. Like at this particular time, I think I've done 20 something videos. Not 20 something, like 12, maybe like this is the 12th in this season. So I'm happy. So what are we going to be doing today? I'm looking at Cournot model. I don't know if that's a pronunciation, please. So do forgive me, but I know how to spell it and I know how to like solve questions around the Cournot model. Then we have the stackelberg model or stackelberg, whatever. Okay. Apologies to um, the guys that have those names. So for the Cournot model, it is this both models are just models that are used to like I'm trying to explain the behavior of duopolists like in the industry. So remember that the industry's demand is a function of the output of both firms, right, in a duopoly market structure. So for the Cournot model is saying that both firms simultaneously um, produce a particular quantity of goods and services, like not the same, like but it is simultaneous decision, right? It's not as if one person has to decide first, the other person then decides later. So it's simultaneous decision, like both companies just individually choose the output that they are going to produce, and then after doing that, the price of the goods in the industry is then determined, and from there can go and solve for the profits of the companies involved. Now, but before I proceed, so the Cournot model is also called like the simultaneous output determination model, something like that. Yeah, or simultaneous quantity setting model. Because output, the firms just choose their own outputs like on their own, right? So, and once they've done that, the interaction of those output then goes on to determine the price in the industry. But then for the other one, which is Stackelberg model, which is also called the sequential quantity setting model, both of them are all about quantity setting. So they are that are like the competition is not price. Like the price is the same thing for all the firms, or for both firms, but the competition is in the outputs, produced or the output sold, right? So for the Stackelberg model, we have a leader in the industry. So it is that leader that the second firm will now be looking up to. So the leader chooses his or her output first, right? And their output that the leader is choosing is dependent on how the follower, okay, is going to react. So before, let's say between let's use Windows and Linux, for example. So Windows wants to like produce a particular quantity of its software, its services, and then it looks at how Linux is going to react. So it considers Linux reaction, right, in the determination of its own output. So before Windows say that okay, this is the output that we are going to produce, so I've looked at it, okay, what will Linux do? So what Linux is going to do then, it incorporates it into its own decisions and then finally choose the output that is going to produce. So we'll solve both of them mathematically for you to see what I'm trying to say. So, but for Cournot model, it is simultaneous quantity setting model among the duopolists, and for the Stackelberg model, it is sequential quantity setting. So there is a leader. So the leader goes first, then the follower, then does what he has to do. So I'll be solving a question on the board, and I'll be starting from the point of a monopoly. So where the firm was a monopolist, right? There was no competition. Then it became a duopolist. Okay, under the Cournot model, then a duopoly under then we assume that it's also a duopoly under the Stackelberg model. So we are going to see the respective quantities and prices that are going to be generated in these three scenarios. All right, so there's this question that says that in Ondo town, right? Ondo town is in Ondo State in Nigeria. In Ondo town, there is just one supplier, right? One chicken farmer that is supplying eggs. Just one chicken farmer that is supplying eggs. So is production his marginal cost of production of producing eggs is assumed to be zero. That's not possible, right? Like I just to make things simpler. So his marginal cost of producing eggs is zero, and then the inverse demand function is given as 100 minus 2q. All right, so his own is the MC is the only one there. MC is equal to zero. Then the inverse demand function is 100 minus 2q. 100 minus 2q. So our job is to then find the quantity that maximizes is equilibrium quantity or the quantity that maximizes its profit, and the corresponding price. So I don't think I calculated profits, but we can do that. Okay. So when is a monopolist, we just quickly change this one to MR. So I can just do this 100 minus 4Q. So right now you should understand what I just did in that place. So, but don't do like this now, like I'm warning you. So find equilibrium output. To find um, equilibrium output, comma. So we're gonna be having uh, MR equals MC. So 100 minus equals 0. So 100 equals 4. So you divide both sides by 4, divide both sides by 4. Q equals 25. So Q is 25, then price. You must be so used to this kind of questions now. So price is going to be equal to 100 minus 2 into bracket 25. So the industry price is 50. All right. If our MC is 0, how can I even get my total cost? Since MC is 0. So if I start to integrate 0, I'm not even going to get Q. So I can't even find my total cost. That's the point. So total revenue. Let me just do that one here. Total revenue is going to be equal to P times Q, which is equal to 25 multiplied by 50. So 25 times 5 is 125. 1250. So that's my total revenue. So I can't find my total cost because I don't have variable cost, I don't have fixed cost, and I cannot integrate MC. So if I no, I can't integrate MC, but if I integrate it, I'll still get 0. So it's not like a definite number. So this is it. When this firm is a monopolist, its currency is 25, then its price is 50, its total revenue was 1 to 50. Now under the Cournot model, so this is A, and there is B. Now there is a second firm. The question, the next question says that now, suppose a second chicken farmer who also has zero marginal cost moves to Ondo town. So what quantity will both farmers produce and calculate the price? So what quantity will both farmers produce and calculate the price? So there's a second farmer now, which means this guy is going to change. So P is now going to be equal to 100 minus 2, not just Q now, it's going to be Q1 plus Q2. So what we are doing here is applying the Cournot model. All right, so we are going to be doing partial differentiation here. But first, let's find out TR1 because we need MR1, MR2. So let's find out TR1. TR1 equals PQ1, which is equal to 100 minus, let me just open this one up, minus 2Q1 minus 2Q2 multiplied by Q1. So I'm looking for Q1 first. So my TR1 is equal to 100 Q1 minus 2Q1 squared minus 2Q2 Q1. So where's my marginal revenue for 1? So MR1 is D, TR is slanted D to show it's a partial differentiation. The TR then the Q1 equals, I'll be having 100 minus 4Q1 then minus 2Q2. Okay, so this is my MR1. So to find equilibrium output, to find equilibrium Q1, so I just say MR1 equals MC1. Since they have the same marginal cost, so I can call one MC1 and call the other one MC2. So that means we are going to be having 100 minus 4Q1 minus 2Q2 equals 0. All right. So from here, 4Q1 plus 2Q2 will give us 100. You can solve it properly on your own. What I just did was leave 100 here. Take this minus, take it to this other side. They will become positive. and the 100 here too is positive. So I could just decide to put what I took here, bring it to this side. Just mathematical multiplication. Just do it the way you understand it. I didn't name all of these equations, so let me just, please don't follow this bad habit of mine. Let me just name this equation 10 arbitrarily. So we have the equilibrium output function for FEM 1. So we have to do the same thing for FEM 2. We come back, TR2 is going to be equal to PQ2, right? Which is going to be 100 minus 2Q1 minus 2Q2 multiplied by Q2. So this is going to give me 100 Q2 minus 2Q1 Q2 minus 2Q2 squared. So what is going to be my MR? MR2. MR2 is equal to 100 minus 2Q1 minus 4Q2. Alright, all of this one should not be a problem. All this small differentiation that we are doing. So to find equilibrium Q2, so what we just do is set MR2 equal to MC2. So the question told us, okay, start from here for the sake of space. So MR2 is 100 minus, can you even consider that piece? I don't think so. So 100 minus 2Q1 minus 2Q1 minus 4Q2 equals 0. So we are going to be having 2Q1 plus 4Q2 equals 100. So I call down my equation 11. So you can see that what we are having is a simultaneous equation. So I don't want to stress myself out. So I could just combine equation 11 and 12. So when we try to do that, so I could just from here, I could make Q1 the subject. So 2Q1 equals 100 minus 4, then Q2. So divide all through by 2. Divide all through by 2. So Q1 equals 50 minus 2Q2, equation 12. So I could just put equation 12 in equation 11, like normal simultaneous. So I'm going to be having 4 into bracket. I can't put equation 12 in equation 11 since we got equation 12 from equation 11, so I can't put it there. So I have to go and put it in the alternative equation. This is, it shouldn't be a problem. So 4 then, Q1 is this, which is that. So 50 minus 2Q2, right? Then plus Q2 equals 100. Plus Q2 equals 100. So 4 times 50, or yeah, 4 times 50 is 200. 200, and 4 times minus Q2, that's minus 8Q2. Is this going to be correct? Okay. Plus Q2 equals 100. I'm already looking at what is going on there. I'm not sure. Okay, we should be having a decimal, but I think we'll be having a decimal. Alright, so minus 8Q2, then Q2 here, and this is Q2. So we're having minus 7Q2 equals 100 minus 200 is minus 100. Cancel this, divide by 7, divide by 7. So Q2 equals 100 divided by 7. Don't have anything like that here at all. So that will be 16.67. 16.67. Okay, let's quickly do it 16 times because that was not the approach I used to in solving it. It's 16 times 8, 16 times 8, 8 times 6, 48. That's 1, 8. So it's 16, it's almost 17. It's 17 times 7. Okay, it's possible. Alright, so 16.67. Now, how do I get my Q1? So I can come back. Since Q1 is this, right? So I could just do that one here. So you can say I'm not really doing it, sequential, like the only just put that on the board, but at least try to follow. So Q1 is here. Where is it? Is here 50 minus 2 Q2 will be 50 minus 2 into bracket 16.67. So Q1 equals is 33.33. 50 minus 33.33. So Q1 is going to be 16.67 as well. So Q1 and Q2 are both 16.67. What then is going to be the price? What is going to be the price? So let me see if I can just do the price. It will do anything for price. So this is price. Let me just do the price up here. So P is going to be equal to 100 minus 2 into bracket 16.67 plus 16.67 plus 16.67. So P equals 100 minus 66 point 7. Apparently 66.7, and P is going to be equal. So then P is equal to 33.33. So I want us to compare our answers. Initially, when it was a monopolist, P was 25. So let's just write something here. When it was a monopolist, Q, let's do something like this. You have Q, you have price. A monopolist, Q was 25, price was 50. When it became a duopoly under the stackelberg model, Q is not just 25 now, right? Q is the output of both firms. Remember, that will be 16.67 plus 16.67. So that will be 33.33. So because this is industry's output, 33.33, and then price too was 33.33. So we see that on when competition arrived, right, the industry's output increased, right? And then the industry's price fell, which means competition is good. Do you understand? So this is like kind of better for consumers. So this is okay. And let's also look at what is going to happen if one firm had gone first. So if this industry happens to have a leader, right? So B is for the Cournot model. So C now is going to be for the stackelberg model. Before I erase the whole thing up, so that we can solve our stackelberg model, I was wondering somewhere that this 100 divided by 7 was questionable. So I forgot to write this is 4Q1 plus 2Q2. So this is plus 2. And if you had on your own, you'd have gotten it anyways. So this is meant to be plus 2Q2 because every other thing is correct. I just knew that I was meant to get 16.67 there. So this is going to be 6 here. This is 6. Okay, so just note that. So I apologize for that mistake. Okay, so let's now go on to the stackelberg model. So in this scenario, where there is a leader, so firm one, the first guy that was selling eggs, the first chicken farmer that was selling eggs, is now the industry leader. The one that came after him is assumed to be the industry follower. So, the second firm is the industry follower, which is going to produce output 2. Now, if you remember the theory that I told you about the stackelberg model, is it was about the industry leader trying to figure out its own output and then putting into consideration the reaction of the follower. So it considers the reaction of the follower in the setting of its own output. So that things are really going to go well with it. So it doesn't just set and then allow the followers to do what they are going to do. Like we're trying to set how will this other company react to what I'm going to do. So it considers that and then set its own output. So what we're trying to say mathematically is this. Now we are going to find the process, or we are going to find the equation for getting output 2, right? We are going to find that one first for firm 2. So for firm 2, I don't even know why did I even erase it. So we had P Q2 equals like this are TR2 equals 100 minus 2q1 minus 2q2 into brackets q2, and then that gave us 100 q2, or that gives us rather minus 2q1 q2 minus 2q2 square, and then mr2, which you already know how to do, 100 minus 2q1 and minus 4q2. Then to get the maximizing output, we've done all of these things before. So mr2 equals mc2. Again, it is because I'm just using this to teach, and I've told you what the normal process should be. Don't just write this for a lecturer. Show all your workings. So 100 minus 2q1 minus 4q2 equals 0. And from here, 2q1 plus 4q2 equals 100. All right, we are going to make q2 the subject here to get the q2. So 4q2 equals 100 minus 2q1. Divide both sides by 4. Divide both sides by 4. So q2 equals 100 divided by 4 is 25 minus 0.5 q1. You see this thing that is here? This thing that is here is what we call the reaction function. Reaction function, let me just put it on that to save that space. So this is known as the reaction function for FEM2. Reaction function for FEM2. All right. So from the word reaction, what will you do? Do you understand? So you can also get the reaction function for FEM1. So all you just have to do is get the, what do you call it now? Differentiate this with respect to like up to 1. All right. And then the function I get is going to be the reaction function for output 1. So what is now going to happen is that, you see, the leader will consider this output, this function here, in setting its own output. So for P2, for you to get your under the stackelberg model, so our P is now going to be equal to 100 minus 2q1 minus 2q2, right? But that q2 is now going to be equal to 25 minus 0.5 q1. So P equals 100 minus 2q1 minus 2 times 75 is minus 50, then plus q1. So P equals 100 minus 50, which is 50, minus CQ1 plus Q1 minus Q1. So this guy can now continue from here. CR1 equals P multiplied by Q1, which is 50Q minus Q1 squared. And then MR is just going to be equal to 50 minus 2Q1. Now recall that MC equals 0. Okay, or MC1 equals 0. So 50 minus 2 Q1 equals 0. Q1 will be equal to 25. What then will Q2 be? So the leader is going to be producing 25. And then the follower, which is this, Q2 will be equal to 25 minus 0.5 of Q1. So 0.5 is half of Q1, which is 25. So Q2 is going to be equal to 12.5. Right, so industry's output Q is 25 plus 12.5, which is equal to 37.5. So which means that here, that is stackelberg model, we are going to be having 37.5 here. What then will now be the price? What will be the price? So come back to the even solve of the price here. So because we can't just use this one to set the price. Remember, we can't use, what is it? Can't be using this one to find the price. So why can't we use these guys to find the price? This is not just function of Q1. But then price is the price in the industry, not just the price to a firm. So we come back to this. So P P equals 100 minus 2 into brackets 37.5. So equals 100 minus 75 equals 25. So price here is 25. All right. So then if you were to calculate their profits, okay, their MCs are zero. So the thing is that the leader in the stackelberg model, the leader is able to produce more output and get more profit, like generally than the follower. It has that edge. You understand? So it has that edge. Unlike in the um Cournot model. Why did I even put a D here? This is monopoly. Okay, let me call it like a Cournot model. So DC, duopoly is under the Cournot model, and duopoly is under the stackelberg model. All right. So monopoly gave them like the worst outcome. Quantity was just 25. Price was as high as 25. The Cournot duopoly gave us a better price, um, a better output than the monopolies. But then the Stackelberg gave us something better, or the best. It gave us the best among the three. The 7.5 industries output, then price fell to as low as 25. So which one do you think consumers would prefer? Of course, consumers are going to prefer Stackelberg duopoly. So you can try to like figure out what the consumer surplus would be, for the two firms. So did I ever solve that? I think I was trying to look at okay, I only did the consumer surplus for the firm when it was a monopoly. So how would you, of course, before now you should not calculate consumer surplus. So we have, what was the demand function for the monopolies? It was just P equals 100 minus 2Q. Just okay. When Q equals 0, P is going to be equal to 100. And then when P equals 0, Q equals, is that not 50? 100 comes there, Q equals 50. It's also the same thing for the duopoly, because instead of writing just small q here, for the duopolies, we are going to put like the big Q, because we are more or less talking about the industry's output. But then you still get P as 100, Q as 50, for that one too. Or let me just leave it as big Q for all of them. Right, so you are going to have this. So for the monopolist, the demand curve is like this. Price is on this axis, quantity is on this axis, 0. So what we just did here, this maximum that we got, this 100. So when your output is 0, for you to be watching this class, you have to be in 300 level, like and above. So like all this should not be a problem. So here is 100, then the quantity here is 50. Just trying to draw the graph. Now for the monopolist, his own price was 25. Um, Price was 50 rather. His own price was 50, 50, and then this one here was 25. So consumer surplus CS is basically half base times height. So I'm looking at all these parts, this rectangle, this triangle rather, triangle A, B, C. So what is the base? Base is just from here to here, 25 minus 0. So you have half times 25 times, what was the height? Height is from 100 to 50, so that's times 50. 2 here, 1, 2 in the whole thing, so you have 625. The consumer surplus when the firm was a monopoly was 625. So how about the consumer surplus when the firm is now a Cournot duopoly? So the same, we still have this guy coming down. So we're having 100 here, we're having 50 here, 0. But the price now is now 33.33. I know price was 50 here, so price is lower here, 33.33. And then outputs, industry's output was also 33.33. It's not always like this though, so don't think it's always like this. So again, triangle ABC. So the CS, where you have a Cournot, let me call it CS Cournot duopoly CSDC, half base times height, half times what is the base from here to here? 33 minus 0, 33.33, then multiply by height is 100 minus this, which is going to give us 66.67. 66.67. By the time you're done, you'll be getting 1110.69. Is this 69? Solved it somewhere. Can't find it. But it's 110.69 anyways. Whether I can find it or not. 110.89, yes. 0.89. Okay, I tried even recording it. Now for the of course, since this one is giving us 37.5, under the Stackelberg duopoly, we are going to be having eh? We have this. This one is still 100. It's still 50. 0. Yeah, put 0 in the rest. Okay, good. So the price fell as low as 25. The price fell as low as 25. Industrial outputs increased to 37.5. 37.5. You can see the way I'm like drawing it here. Price was high. So 50 was closer up. But just midway, yeah, price has come down. Yeah, the price has come like it's further down. So like just look at the distances that I'm putting there. Right? So how I'm denoting these numbers and how I'm denoting these numbers too. This one is getting closer to 50 than this was to 50 or than this was to 50. So again, A, B, C, our CS is half, the base is 37.5 multiplied by 100 minus 75. So I'm seeing the same pattern, 37 point, I'm seeing the same pattern. So this is 37.5 square. I don't have a calculator here. So CS is this. If you look at this one, so divided by 2 in this is 33.33. So this was 33.3 square and this was 25 square. Alright, so this guy is better. So the Stackelberg model is like really better for consumers, among all of these three things. So there are still other um, models. I think Duesenberry, is it Duesenberry or something? Um, there's Cournot, there's Stackelberg, there's one that I can't really remember now. That one is based on price. So instead of competition based on output, where there's a given price, the products sold are homogeneous. Like that's the assumption of these two models. Like one of the assumptions, like they're selling the same goods. Products sold are homogeneous. But that one is looking at do business really compete on output? Like don't they really compete on like based on price? So that model is based on price. I used to remember it, but I don't know why the thing just flew over. Yeah, Bertrand. Thank you, the Bertrand model. So, but we are not going to be talking about the Bertrand model now. So maybe in the future we'll make a class on it. So I believe you understand these things. Just sit back, enjoy it. It's not a problem. Enjoy it and practice on your own. You're going to get it, and you're going to be cool. So we have our assignments to focus on now. Here comes the assignment. It's one of the exam questions of a particular school. Now, assume a duopoly industry with the demand function P equals 100 0.5. So the quantity is represented with, or the quantities are represented with X here, not just Q. So here, the cost function, the total cost function of the first firm is 5x1, and for the second firm is 0.5x2 square. So this one is just 5x1, there is no square. This one is 0.5x2 square. Now, the thing is, no, yeah, they give us total cost. There are questions that may want to like take it a little deeper. They will give the marginal cost function and then give you the fixed cost, right? So what do? You have to, in that case, from your maths now, you have to integrate your marginal cost. But when you integrate your marginal cost, what you get is your variable cost. Then whatever fixed cost you were given in that question, so you then add it. So except you were told that the fixed cost is 0. Now, what do I mean? If your MC, was given as x just x, right? So your TC is integral x, which is going to give you x 1 plus 1 over 1 plus 1 plus c, constant c, and you are going to be having um 1 over 2 x squared plus constant c. So your TC function, the one that has the x, the one that has the quantity is the variable cost. The one that you just see is the constant. So if you are told in the question that the variable cost, the fixed cost rather is 0, then that means TC will just be equal to half x squared. But if you're given a value for your fixed cost, let's say value of 10. So if fixed costs FC equals 10, then that means that the total cost function that you're going to be using, your TC or your C, have been half x squared plus 10. So all of these ones that we've been doing, they are simple things. This one too is simple, right? It's not as if it's going to be like that crazy, crazy, crazy. But I just want you guys to like take note of that, just in case your professors, lecturers want to like move in that way. So don't let them catch you off guard. You know these things. Do you understand? All right. So using the stackelberg model, A, derive the reaction functions for both firms. So the other time, because we already had a leader, so we did the reaction function of the second one. But in this case now, like there's no leader yet, so just derive the reaction function of both firms. And for B, B is now telling us if firm one is now the sophisticated leader, okay, then calculate both firms' profits. Apply what we did in the lesson. So will you be needing the two reaction functions? No, you'll be needing only one. Now, number two, solve question one with the Cournot model and write a summary of your deductions. All right, so you solve, so everything that you solve there, so you compare them just the way we did a comparison for the example. So I wanted to say something. Where I got this question from, the PQ that I got this question from, this place was a minus. I solved it, like I've solved it. Minus is not right. Theoretically speaking, I do not, okay, let me put it that way. I do not think that a minus there is right because it should be a sum. Like your industry's output should not be a subtraction of the output of the firms you have in the industry. So industry's output is like a market demand. So a market demand cannot be a subtraction. So market demand should be addition of all the demand, all the quantity demanded by different people. The same as your market supply. So you're adding all of your quantities at a given price. Do you understand? So as correct this to plus, I don't think it's supposed to be minus. So that's my personal opinion. So yeah, that's it, and that's my last class in this particular season. All right, I know more is going to come in the future. Thank you so much for this 30 something that you spent with us. See you when I see you again.